My name is Ricky Brundrett. I'm a senior technical program manager on the Azure Maps team. How many of you have ever heard of Azure Maps? A couple? All right. So if you're not familiar with it, Azure Maps is a newer product. We went live at the Microsoft Build Conference in May. We're part of the Azure IoT team. You might be wondering why Maps in Azure IoT. Well, with just about every single request you get from a device, there's two pieces of information that always exist. Timestamp, and then space or location. And so Azure Maps is the location part. We bring your location intelligence. So with that in mind, Azure Maps platform, we have a whole bunch of developer APIs that help you do everything from calculating routes, visualizing data on a map, doing search, traffic data, and a lot more. Why is this important? Oh, give me my updated slides. So 80% of all business data has some kind of location intelligence context to it. And so by using Maps or Azure Maps, you can unlock that information. We also, so we went live in May. In July at Inspire, we made a big update and we added a bunch of new services into preview. So going beyond just standard, maps, routing, and search, we went in and started adding things like route matrices or distance matrices and time matrices, route range or isochrone. So those are kind of like, all right, I know I'm here. Give me a polygon to show me everywhere I could be if I walked in any direction for 5 minutes. And, or the opposite of that, I generate a polygon that it would take someone 5 minutes to get here. And that's quite interesting when you think of like delivery scenarios where, hey, I want to set up this alert. So if anyone, the delivery guy is within 5 minutes of my house, send me alert so I can go through and be ready for that guy rather than me being at the, in the garage or something. I can be at the front door waiting. We also have a boundary data. So, a lot of people, when they go to maps, they say, oh, I need, state boundaries or I want county boundaries. And a lot of times they have to go and bring that data with them or find a source of that data. We actually have that already built into our platform for rendering, so why not expose that and make it easy access? Another common service that we released that we had a lot of requests for is just a simple IP address to location service. A lot of times you just need a rough location of where someone is, like, hey, I want to know what country they're in, so I know what user region settings to use for my map or for my site or what have you. And that can help you figure that out very easily. And then we have batch geocoding and routing, and this is actually something where, you can go and make individual calls to our services, and then, you might say, oh, well, I have 1,000 addresses I want to, find the coordinate for. Well, instead of making 1,000 requests, you can do that in one request with the batch service, and it'll process in a few seconds, so it ends up being a lot faster than making 1,000 requests, and it also just simplifies the whole process as well. Now, what we're announcing today is, or technically yesterday, is we made a big update to our web map control. So we made a lot of developer API improvements. So we made it backwards compatible, but we add a lot of new things and re-architected a lot of things, which unlocked a lot of scenarios and improved performance. It also makes it a lot easier to understand how things fit together. We also added in what's called data-driven styling. So a lot of times you might say, okay, I have this, all this data, but based on some metric on each data point, I want to style it differently. Well, rather than going through and writing several lines of code, with if statements and switch statements to go through that data and then create a different style for each one individually, and then only to then pass it to the renderer who has to loop through the data again, what you can do is right when you specify the style for a layer in our map, is you can specify business logic right in line, and I'll show that in a little bit. And what that'll do is that business logic then gets ran against that data right during the rendering phase. So rather than looping over the data once to style it and then looping over again to render it, we do it all in line in one step. So now it's half the loop so we can render a lot more data. We added a spatial math library. There's a lot of times where people just want to get the straight line distance between two coordinates. That's a formula called the Haversine formula. And I've been doing this for 12 years, and up until we had a library, I probably had 1 or 2 people a week ask me, oh, how do I calculate this? And then I'm like, well, here's a copy and paste. type thing from some site. And there's a lot of other common formulas like that. So we've added them all into a library, built it into the math library, so you don't have to go looking around, copying and pasting all this code. It's just there, and a lot of it is just one line of code to do that. Now, if you want to calculate distance, it's atlas.map.getDistance2, and then you pass in your locations, and it calculates that distance. And then another big update we did was, so we added support for geospatial circles. That might not sound like that interesting, but a lot of 2D flat maps use what's called the Mercator projection. So, if you take the globe and you cut it open and try to make it flat, it's not a square. But for visualization purposes, for online maps, we want a square, and so we stretch the maps out near the poles. And so what happens is you go and you put a circle on the map, and if you, depending on where you go, a circle might be one size at the equator, but that exact same diameter in real world radius or distance is actually rendered larger when you're near the poles. And so a lot of people don't realize that. But that's really important, especially if you're doing like GIS type visualizations or trying to show an actual area. You need that to be accurate. So that's it for the slides. We're going to jump right into demos now. All right, just double check. Yeah, all right, we're good. All right, so this first demo here combines a bunch of our services together. So the idea is, all right, you want to calculate a route from point A to point B, and then we're going to animate someone driving that route. But as they go along, we know one thing's always going to happen when you drive a vehicle. You're going to lose fuel. You're burning fuel. And so it's going to go through and at different points throughout the route, calculate an isochrone based on how far it thinks it can go, and then use that isochrone, or that polygon there, to then do a search against our point of interest data for gas stations. So you can go through and get an idea of, if I need to stop, where are the nearest by gas stations that I can actually make it to. So we're going to do a simple query here, Redmond to Seattle, a route we take quite often from where I'm from. So now we have this route drawn on the map. We see a couple of gas stations shown along the route. But now we decided to animate it, and we see this vehicle going way over the speed limit, of course. And now, all right, looks like traffic's pretty clear. They can make it pretty far. And as they go on, they stop again. We see that isochrone's changed because now they can't go backwards, on the bridge. They have to actually go to the end of the bridge, turn around before they can get across. So in this case here, they made it all the way. This demo here is actually using live traffic data. So it's, right now, back in Seattle, I think it's like 9 or 10 in the morning. So it's not too busy right now. The rush hour is just finished. So that's why he made it. But most of the time when I run this demo, he doesn't make it to the end. The next one I wanted to show is, so we have this, a lot of our code samples, so except from the one I'm showing, I'm still working on porting that over, but all our code samples are on GitHub, and we have a website where you can go through and view them as well. And so you can go through and easily find different examples here. So the next one I want to show here is car versus truck routing. So our routing service not only does car routing and truck routing, but you can actually do taxi routing, commercial van routing, bike routing, walking directions, and then for the motor vehicle routing, you can actually specify if it's a combustion engine or electric engine, and there's a ton of other features as well. But we're just going to take a look at just route versus truck. So we're going to open up this sample here, and we'll see, this is just a small subset of the options, but we're going to take a look at a couple examples here. So the red line here represents the route a car can take. But for this scenario here, actually right at this little intersection, there's a low bridge, so this truck can't fit into that low bridge, so they have to go around and take the long way around. And so their distance is about, 50% longer. Now we're going to take a look at another example. So maybe someone's trying to have a moving truck bring do a delivery or drop off people's furniture, and but it's a long semi. They can't do a tight turn, so the red car can make this tight turn, but the semi can't, and so the semi has to go around the block. And so this is about 30% longer than the car route. So that's important information when you're trying to do travel time estimates, fuel estimates, and things like that. Now this one's quite interesting. So we see this road here. The car takes a straight line through the Liberty Tunnel in New Jersey, I believe. But the truck can't, because the truck's carrying flammable materials, and flammable materials aren't allowed to go through the tunnel. So we see this truck has to take this really long route, and they nearly go twice the distance. And so, if you're trying to do predictions on when a delivery is going to make it somewhere, or whether that be a food delivery, or you're carrying hazardous materials, this could really make a difference in your estimates. And then same thing with fuel consumption and things like that. So the next thing I wanted to show you is data-driven styling. So this is the actual functional code. So what this sample is doing is it's tying into a data feed from the U.S. Geological Survey or Service, and it's pulling in significant earthquakes from the past month. And so every time I run this demo, it queries the latest data. So if there's been an earthquake recently, it'll show up in here. So with this data, each data point has a magnitude value. And so based on that, I want to scale the size of that circle based on the magnitude. And I also want to color it based on that magnitude. I'm also doing a little extra work here to do some putting the actual magnitude value right on the circle. Now, let's take a quick look at the source code there. And here we are in GitHub, and I'll zoom in a bit here so we can see this a little bit better. So we download our earthquake data, and now we add it to the data source, and then with that data source, we then connect it to a layer. So I'm using a bubble layer to create my circle. So we have two different types of circles. We have the bubble layer, which are pixel accurate circles that, if you make it 40 pixels, no matter what zoom level, it's always 40 pixels. Then we have the spatially accurate circles that I talked about that are kind of like polygons on the map. They don't change. They always represent the same area on the map. So in any case, so we see this example here for the data-driven styling where, okay, for the color, I want to do a linear interpolation on the magnitude property. So I tell it the property here. If the magnitude is 0, color it green, or 0 to 4 or 5, color it green. From 5 to 6, color it yellow. From 6 to 7, color it orange. And anything above a 7, color it red. Similarly, I have another interpolation for the radius, and or another data-driven style for the radius based on the magnitude value. So if the magnitude is 0, make it 2 pixels in radius, or 2 pixel radius. And if it's a magnitude of 8, make it 40. Anything in between, do it a linear interpolation. So a real simple algorithm or bit of information. Whereas if you try to go through and imagine writing this code step by step and then loop through your data, besides the fact that you'd be looping over your data twice because of the adding the business logic and then the rendering, you would also end up writing a lot more code because it just wouldn't fit in so nicely like this. Another neat thing, so sometimes we can apply some more advanced queries against the data. So in this case here, I want to take that magnitude value and I want to concatenate the letter M to it and then use that for my text value on the above the bubble. So a real simple thing there, but it just kind of shows you that it's not just about numbers. We can also do transformations on other types of data in the styling functionality, which really reduces the amount of code you have to write and then also really improves performance. So on that note, I want to show you my demo that tries to break our maps. So this here has 167,000 shapes on it, approximately 8 million coordinates, and just under 140 megabytes worth of data. I preloaded this one here just because it takes forever to download the data on this internet connection. But all right, getting a simple map to render and display this much data in a browser is not easy. I had a customer recently that's moving off of another major mapping platform due to their recent increase in costs. And we started off the cost. He's like, yeah, when we migrate, we want to do all these things because the performance is horrible. We have 35,000 push pins we want to put on the map, but it's horribly slow. So we have to do all this back-end server logic to optimize everything. And I said, well, here, let me show you this demo. And so once he saw this, he realized that all this, 2 months of migration, he was back-end server stuff that he was going to build out to help his performance, he doesn't need to do because the map can already handle that. Like the 35,000 data points ended up being about 3 megabytes of data, which is a small fraction of what we have here. But rendering it and seeing it flat like this is one thing. Being able to interact with it is a totally different thing. So we see just how smooth that is. Now, with the polygons here look very generalized or really basic, and that's because by default, so everything's rendered in vector data inside of WebGL, and so when I was zoomed out, it reduced the resolution of the data for fast rendering. When I zoom in, it's kept that resolution, and now it's going through and it's improving the resolution. And so, actually, I think I already figured, yeah. But yeah, if you give it a little bit of time, this case here, it'll actually render the high resolution version of the polygon. It just takes a bit of time because of the sheer amount of data. But so that just kind of shows the power. Like, you can imagine this much data and being able to pan and zoom very easily is not something that's easily available on a lot of other map controls. Another cool thing I want to show you, so we have this concept of a data source and a layer, and you can imagine, like, okay, maybe you want to have a drawing tool. You want to draw some polygons, and so we, let's go here, and so let's draw a polygon. So when you draw a polygon on a map here, we can see a couple of key features, and actually I'll come to the screen to show you. So we have our filled in area of that polygon, we have an outline for that polygon, and then we have a little handles or little push pins on each coordinate of that polygon. So when you use most map controls, you would have three copies of your data, one to create the polygon, one to create a line, and one to create, well, several data points, so in this case, 4 push pins you'd have to create. So that's 3 times the amount of data for representing one shape, just rendering it 3 different ways, essentially. So what we've done is separated the data source from the layer. So now we have one data set, one copy of those coordinates, and then we specify the different ways we want to render it in each individual layer. So now we only ever create one copy of the data. So that's how come we're able to render so much more data and get good performance as well. And it's great for memory management. So going a bit further, so with the idea of layers, let's see, where did I put this here? All right, so we have a whole bunch of options for styling layers, and we have these nice little tools that you can use to test them out. And so we're going to do the simple tile layer. So if you're not familiar, so in order to do or provide a world map for every zoom level, we have to break the map up into these little blocks or little images that we call tiles. And so this tiling system, you can actually break your own images up and match that system. And by doing that, you can take really high resolution images and put them on the map and not have to worry about, trying to load a 50 megabyte image into a browser that the browser can't handle the rendering, because now we're doing these little images instead. And so in this case here, I've taken a NASA imagery. I think this image here originally was about 400 megabytes in size, and I've tiled it, broken it up so that it fits into the same tile system as the map. But we can go through and do not only render it on the map and overlay it, but we can do some really cool styling to it as well. So we might say, okay, really simple thing, let's change the opacity, or transparency. You might see this first option here, which is fade duration. That's actually for when I turn that layer on and turn it off, it'll actually fade in and fade out rather than just disappearing and coming back. We have other things like the contrast, so we can go through and modify the image. And then we can do hue rotation, which gets quite interesting with the colors. And then let's go do some, change the saturation. We can get some really cool things like this here, where now we can actually see, in this case here, the only thing that was really white were the clouds, and we can actually see where the clouds are the densest, and which is, of course, in the center of the hurricane. And all that's, very easy. In fact, to do all these options, that's the code that I have to add into my layer. 2 style or 2 options, everything else is using the default. So pretty simple. Now, as much as we have into our map control and as much power we put into it, there's a lot of great other map controls out there. A lot of them are open source. So if you work in mapping, you might have heard of Leaflet or OpenLayers or Cesium. And so that's the great thing about our platform is all our data is service driven. And so all of our map tiles, both vector and raster tiles, are available as services that you can pull into other map controls or other platforms if you wanted to. And so if I come down here, we can see a bunch of examples of how to pull it into different map controls. And so we're going to load up this one here. This one is a bit slower to load, but it should be worth it if it loads. All right. Okay, I'll have to double check that one there, but we'll take a look at another one. So yeah, if you're not familiar, Cesium is a 3D map control, which works in the browser. It's pretty cool. It has a lot of 3D rendering capabilities. Leaflet, on the other hand, is a flat 2D map. Been around for over 10 years. I've been doing this for a long time. I remember when it first came out. But it's basic JavaScript map, 2D maps. It does a lot of its rendering with SVG, so it doesn't have the same performance as what we have, but there is a ridiculous number of applications out there built on top of Leaflet. And so if you have an app that's using Leaflet today, and you want to start moving over to Azure Maps, you don't need to rip out all your code and start over. It's actually really easy. And so if we take a look at this code sample, and we'll zoom in a bit, we find out all you have to do is add a tile layer that points to our tiles. I've added a little extra code to add the Microsoft logo, but in total, you can do this in as little as about 5 or 6 lines of code, get Azure Maps powering your existing applications. So with that, we'll go back to, okay, I lied. There's two more slides. One slide is there's a lot of Azure IoT sessions, so be sure to check them out. And then I'll open it up to Q&A. I have my email there. If you have any questions that you think of later, feel free to email me. Or just go to azure.com/maps. We got a ton of links there. And so thank you for coming. And yeah, feel free to come on up and ask any questions.